Hi everyone. So today's video is about three topics. First topic is AVL tree. Then we are going to learn about 2-3 tree, and we are going to learn about red black tree. So these are the three different types of trees which are present in algorithms. So now first we'll start with AVL tree. So what is an AVL tree? An AVL tree, the definition of an AVL tree is a height balanced binary search tree. So AVL tree is a height balanced binary search tree. Okay. So what is the meaning of height balanced? Height balanced means the balance factor which is given by height of left subtree minus height of right subtree should be between -1, 0 and 1. Only then the AVL tree is balanced in both left and right side. So here there are four rotations which we can do to balance the tree: LL, LR, RL, and RR. LL means left left. This means left right. RL is right left, and RR is right right. Okay. So these are the four rotations possible by the AVL tree, uh, which we use to restore the balance. Okay, let's see an example problem of how to solve an AVL tree. So the problem says insert the following values into an AVL tree. And I've given three values: 10, 20, and 30. Let's see how do we insert it into an AVL tree. Okay, so first we insert 10 as the root node. Then step 2 we insert 20 like a BST, so it will come to the right side. And right now, so far, the balancing factor here is 0, so it's valid. Here, the balancing factor is -1, it is valid. Now, step 3, we insert 30. Here, the balancing factor is 2, which is not valid, so we have to balance the tree. So here we'll do a left rotation. Why? Because we'll push 20 and 10 to the left. So when we do the rotation, the tree becomes like this. Here the balancing factor is 0, so it is valid. So like this, you have to check the balancing factor in every step of insertion to make sure that the AVL tree values have been inserted correctly. So this is all about AVL tree. The next concept we have is 2-3 tree. So by the name itself, we can tell that 2-3 tree means every node has 2 or 3 children. Okay, 2 or 3 child nodes. Okay, and the second point is the keys inside nodes are always sorted. Okay, and it should be a balanced tree. That means all the keys should be at the same level. So all leaf nodes is at the same level. Okay, so we have to split the tree on overflow. That means if all the leaf nodes are not at the same level, which is called an overflow, we will split the tree. Let's take a problem. The problem says insert 10, 20 and 5 into a 2, 3 tree. Okay, so how do we do it? First, step 1, we insert 10. Okay, so this is single node, so it stays like this. Step 2, insert 20, and then it becomes like this. And then step 3, insert 5. When we insert 5, so when you insert 20, right, it becomes like the tree array becomes like this. And when you insert 5, the array becomes like this. So there's an overflow because it should come after. It can't come before. So because it's coming before, there's an overflow. So the tree will look like this. So there's an overflow because all the leaf nodes are not in the same level. So we'll balance the tree by splitting the tree into two parts. Which will ultimately make all the leaf nodes in the same level. This is called inserting values into a 2-tree tree. Now the last type of tree that we're going to be covering in this video is red-black tree. Now what is a red-black tree? A red-black tree is a BST with color coding. Either red or black. Okay. So how do we define in this? The root is always black. Red nodes cannot have red children. And every path from node to null has same number of black nodes. So it may seem complicated at first. Maybe if once I do the question, you will understand it better. Okay. In this, there are two ways of achieving balance. Recoloring or rotations. So let's check with an example how to do a red-black tree. Insert the values 7, 3 and 18 in a red-black tree. So how do we do this? First we insert 7. So step 1, insert 7, and this will be a black node because root is always black. Then you will insert 3, which will be a red child. Okay, and then step 3 is insert 18, which will be the red child of 7. So how it will look like? It will look like this: 7 black. So we have 2 child nodes, 3 red and 18 red. So these cannot have red children. Okay, so that's all about red-black tree. So these are the 3 different trees that we covered in this video. And so the 3 trees are AVL tree, 2-3 tree, and red black tree. Thank you.